This demo is based on real operational data and energy cost. Here, we have what is called the tree view. It is where everything can be accessed. In the input section, we have folders for the different parts of the site. We have steam plants, which are energy producers. There are 3 fossil fuel boilers and 2 electric ones. We also have heating for building, which heats the air temperature through most of the site, and fill tab process heating, which injects steam into the process. Now we're going to have a look at what is the average energy cost to produce steam. In the trend section, we created a trend for the unitary energy cost using benchmark. This graph is a trend of the unitary energy cost over the last year. It shows how much was paid per gigajoule of energy. The cost varied from $15 all the way up to $30, which is a simple to double variation. This varies depending on various factors. Example, which boiler is used, energy cost, turn down the boiler, etc. To visualize this in average per month, we can go here in Stat 1 and see exactly what this graph represents. Here, this is how much the company paid per gigajoule on average over the year. And this is how much they could have paid. They could have saved over $800,000 if they managed their energy correctly. Next, we'll open EnerMap. One of the objectives of EnerMap is to calculate energy usage for each configured process or component, which is based on the energy balance. This will help us determine which info should be used for gap analysis. The EnerMap view is used to balance one set of data for a fixed date. In this case, January 3rd, 2014 at 4 a.m. We see that the balance is 90%, which means most of the energy produced is associated with energy users. Let's see how we balance over the year. So here we see that most of the year is between 80 to 100% balance, which means the EnerMap configuration represents accurately the energy situation. Once balanced, it's time to see where the gaps are on a cost perspective. The gap is the difference of actual performance with the potential or desired performance. The gap report is divided between heating and process. During the benchmarking phase, key process variables are associated with energy processes in order to track and manage where variations are coming from. The more information available, the more in-depth analysis can be added to the system to localize quickly a problem. From the list, we can select one system where the gap is greater and see which process variable creates the variation. In this case, we see a gap or overheating of approximately 4 degrees Celsius on the room temperature. This temperature difference had a cost impact of $30,000 on the past 120 days. Gap report can be generated and published on the network as required or on a schedule base, let's say every day at 6 a.m. In summary, the total gap for the listed processes accumulates $500,000 on the past 120 days, which is split between heating at $70,000 and processes at $440,000. The larger gaps to be addressed are from Fill Tab 1B, 2A, 2B, and from Air Makeup Unit 82. Only those processes represent around 70% of the total cost reduction opportunities.